All right, so the next world we're looking at is a multi-layer network to do exclusive OR. And if you recall, a perceptron can't do exclusive OR. You need a multi-layer network. So it's not terribly exciting to have a network to do XOR, but we'll get this working anyway as a step towards a more exciting neural network. So if I run it, it can be hard to see what's going on. And I might make a change to show you what's going on. So the four corners are just they seem to be vibrating, and gradually, very, very slowly, two of them are going black and two of them are going white. So what it's doing is it's separating these 2 points from these other 2 points, which obviously can't be done with a straight line. And obviously it took a bit of time to do that. Now, do we have anything in the console? Not much in the console. So what I want to do is show you the code. All right, so when we start the exercise, we'll be cloning and editing. So let's just do that now, and I'll show you something here. So we clone it, we edit it, and we go into the code. There's a lot of things we can change here. We can change the architecture of the network. We can change the learning rate. But this is one thing I think I might actually just change now, just to show you how this thing is working. So what this thing is show all squares adjust the corner squares. So if I just change this to true and run, now you might get a better idea as to what's going on. So it's getting its feedback with exclusive OR. It's comparing its output to the correct output that it should get from exclusive OR. And it's changing the configuration of the network. And gradually it's able to separate these two areas from these two areas, including the 4 points that we're particularly concerned about. So that's actually what's going on. And if we put it back to false, we just see the original, where we've just hidden the rest of it. Another thing I want to show you here is matrix randomize calls this function here random weight. So matrix randomize comes from the matrix library over here, matrix.js, and the randomize function calls random weight. So any world that's going to use that function has to define a function called random weight. The reason I did that was to make it easy to randomly reset the weights. So in our neural networks, it's rather important what the weights start at, and you can experiment with changing the definition of that function. But just to be aware how the weights are initialized, it's with this function here in what's called the tweaker's box. Now, moving on to the exercise that you'll look at after this video. Now, multi-layer neural networks are quite complex, and there's a lot we can change in them, and our learning will be either successful or fail completely, depending on whether we get these things right. So many of the easiest things to change I put in this section called the tweaker's box, where we can just make some tweaks without really having to get into most of the code. So an obvious tweak you can make is changing the number of nodes in each layer, and in particular the number of hidden nodes. So should that be 60? Would that be better? What if it's 1? I think 1 would be terrible. But why would 1 be terrible? How about 2? Is 2 enough? Is 6 overkill? So have an experiment with that and see how it goes. Next one is training data. So the training data really is defining the function. That's the training data that makes this implement exclusive OR. But you could implement your own training data here and change the function that the network represents. The learning rate, what should that be? How much should the network change every time it gets something wrong? Should that be huge, tiny, somewhere in between? Should it change over time? These actually are empirical questions. There aren't any answers that all neural networks should have learning rate 0.2. It's never that easy. So I've shown you before show all how you can look at all the squares, and that's probably a good idea when you're debugging, at least, in order to see what's going on. Here's another good one. Change the definition of random weight. If we make random weight return 0, all the weights are 0, and that's it at the start, what happens? It's not good, by the way. If you make random weight return a constant, what happens? That's not good either, for slightly different reasons. Why is it not good? You need to figure that out. So if the weights are meant to be different, then what kind of range should they cover? We've got random floating point numbers from A to B across that range. How about across a different range? Would that be better or worse? How would that impact the network? So I want you to try all these things out. And so finally, maybe I'll just focus on this and leave you with that, which is exclusive OR is a bit dull of a kind of function. How about you experiment with the training data and get it to implement a very different type of function? And you may have to change the output, the color coding of the output, to indicate exactly what it's representing, because it may be hard to visualize how it's doing on the two-dimensional function. So I'll leave that with you. Get the network to implement something radically different, and you may have to tweak some of these other constants in order to make that happen. So I hope you have fun with that one.